East if you're anywhere near the East Coast of the United States. Um, I am the Rob, and I am um, set up so that I can look over my student's shoulder. Student Owen, sorry, it's like 3:48 in the morning. I haven't had coffee yet, so this is going to be a little haphazard. But anyway, why are we here? We're here because Comet Leonard is coming by, or is on its way, or through our solar system. And so one of our students, Owen, has decided that he is going to actually start taking images of this comet using our telescope here at George Mason. And we're going to peek over his shoulder during this event, and basically just see what the comet looks like. And I'll pontificate on what a comet is, what this particular comet is, and so forth. And so, yeah, I just wanted to. We have these resources here at George Mason. I just wanted to share them with the world, essentially. So. Okay, so before I get into that, let me do this. Let me first start talking about the comet itself. What are we actually looking at here? Oops, that is not what I wanted to do. That's what I wanted to do. So what exactly? What is? I will get into what comet it is in a second. But what are the characteristics of Leonard? Why are we looking at this particular comet? Well, the reason why we're looking at this particular comet is here you can see the current. It's a model of the current state of the inner solar system. You have Earth, you have Venus, Mercury's over there, and you have Comet Leonard over here. And Comet Leonard is going to be a very close approach for a comet. Now, this happens more often than you might think, but it's very rare for us to get such a nice for an object so big and so bright to come by the Earth and actually for us to take a look at this. Now, when I talk about bright, right now, the comet has a projected magnitude of around 7.5 or something of that nature. What that means is it is just slightly too dim for the human eye can see. From my understanding, once it gets closer to us, December 13th is when it will get completely close to us. When basically it will be right about there, or very, very close to the orbit of Venus. Not close to Venus, but very, very close to the orbit of Venus. When it gets out there, I believe it will actually be what we refer to as a naked eye object, where it can be viewed in the night sky. But we don't have to worry about that because we have a telescope. We have a fairly large telescope. It's a 0.8 meter reflecting telescope, Ricci-Cachien, if you are so inclined. And we have an SBIG CCD camera that allows us to take very, very clear images of the night sky. So, I'll come back to that. I will now move on to the main event. And so what you can see here, again, we're peeking over my student's shoulder, and what he is currently doing is setting up a image sequence. So first thing you probably notice outside the comet itself is that the picture is black and white. Now, the picture is black and white for a reason. It's not because the sky is black and white. The picture is black and white because the camera is meant to be what we refer to as monochromatic, or reasonably one color monochromatic. The reason for this is because color matters in astronomy. Color matters physically. It tells us something physical about the objects that we're looking at. The bluer, for instance, the bluer the color of an object, the hotter the object, the hotter the temperature of that object. So hotter stars appear bluer than redder stars, for example. So we can determine that. We can make a measurement of that if we're able to isolate those colors using a filter system and a monochromatic camera. So we could pass in a blue filter, a red filter, or excuse me, a blue filter, a green filter, and a red filter. And not only can we do science with those and determine, say, to a rough estimate what the temperature of the object is, but we can make 3-color images. We can create pretty pictures, as it were. And so this is one of the things that we're trying to do tonight. Is Owen is a member of the Friends of the Student Observatory here at George Mason, and he is taken to astrophotography quite well. And so he is hoping to be able to, as I said, take a series of images. I'm hoping this is not the first night, or the last night rather, that we do this, because again, the comet is going to be, right now the comet is very low, so we have a lot of atmosphere that we're looking through, so the image is not going to be as crisp and as clean as it could be. All right, my cat is getting into trouble. And so, and also it's not as close as it's going to ever be. So I'm hoping this is not the last night that we do this. Preferably it will get either, I actually don't know off the top of my head if it's going to get earlier. It should get earlier as we go along, but who knows? Well, I know it'll get earlier as we go along. All right. Like I said, apologize. I haven't had coffee yet. Haven't planned this real well, but all right. So, hello to anyone again, anyone out there. Howdy. And I am going to. What am I doing here? Howdy, Owen.
Hello.
So we are live on the internets. So I'm basically I'm basically showing them the what you were currently doing on the screen.
Okay.
So I was going to say something relevant, but I've forgotten what it is right now. So what are you doing at the moment?
Right now I just set up the auto save, or the imaging sequence for the comet. So I have 60 seconds in green, 60 seconds in blue, and 20 seconds in red, because the flat fielding is, the weird image artifact is really apparent, and also it's not as bright in red, so it's not as important to catch all the photons.
That makes sense. Comets are typically bluer in color than they are red. There's not a lot of dust to them in the red. Although I'm surprised that the dust tail doesn't appear better in R than in B or V.
Yeah.
Guess we'll have to.
It'll become apparent in processing, but I don't want to stack too much of the ugly whatever this is.
Oh yeah. For those of you at home, what Owen is referring to is that we have recently discovered that either due to light pollution or possibly some minor misalignment in our optics, we are experiencing a brightness gradient across our field of view, and we're trying to track down what that, where that is coming from, and hopefully to be able to eliminate it. So that is the blue image, and now we are moving on to taking the green image.
Okay, I did do BVNR. Mm-hmm. And I labeled them properly this time.
Hey.
I've had issues in the past where I have not labeled them properly. And it hurts my brain trying to figure out what I did.
That's what the FITS file is there for. FITS header is there for.
Yeah.
So 60 in V, 60 in blue, 60 in green, and you said 20 in 20 in R. That's unfortunate.
It'll all balance out.
Mm-hmm.
So I'm not too worried.
So. Yes, that's a comet. I don't know why the R is all messed up. Wait a minute. Are you
Dithering?
Oh, and you're taking all of the. You're not sequentially running through the image or the filters.
Why is it not? Crap. I thought it was.
Go to options.
Default.
Yeah, go to options.
Which options?
Over to the right.
Oh.
Yeah, it's not grouped by slot.
Okay, cool. Run it back.
Yeah, I was like, okay, we should be seeing something other than the B image at this point.
I'm going to put this in the other Discord too.
All right. Okay, there we go.
I don't know how long its ion tail is. Like, in how far it stretches.
Yeah, I'm not entirely certain either. If I have, when we get the visual image or the green image, and I can take a better look at the dust tail, I could probably give you a better estimate as how long the ion tail is. But the other thing that I found, oh yeah, that's right, that's B. The other thing that I discovered was that the coma of the comet is 10 arc minutes in size. So,
okay.
So yeah, there is a lot there that we're not seeing.
Is the coma the stuff directly around the comet?
Yeah, so for you and for the folks back home, there are 4 components to a comet. There is the nucleus of the comet, which we are getting a very good image of now. The nucleus of the comet is really the core rocky or icy rocky body. That's where all of the material which produces the next 3 structures comes from. And this is what the object would look like when it is far out in the outer part of the solar system and it's too warm or too cold for it to do anything. When that ice cube comes into the inner part of the solar system and begins to sublimate or change from a solid state into a gaseous state.
The dome closing.
The dome is closing. No! What is going on? Oh, there's a visual image.
Yeah, we can see the tail all the way to here.
Yeah, I'm thinking that. We'll need to play with the histogram, but first we need to figure out why the dome is closing. Shutter error, although I think it always says that.
Now we go back to open.
No, we have no idea why the shutter is closing.
Shutter's closing because the dome hates us.
Yeah.
There it is.
Oh, okay. Yeah, it's opening back up. Very nice. Yes, indeed. So as the comet gets closer to the sun, like I said, it begins to sublimate, meaning that it doesn't melt, it doesn't go from an ice or solid state to a liquid state, it goes from a solid state to a gaseous state. And when it does so, it forms this bulbous aura, as it were, around the nucleus, and we refer to that as the coma. This is essentially a whole bunch of just water vapor and dust, which is sublimated off the surface of the comet and is now just kind of hanging out with the comet, traveling along with it. When the comet begins to get even closer, what happens is that the sun creates a certain, oh wow, that's unfortunate, creates the sun creates a certain amount of pressure that it exerts onto the comet, and that's what creates the two tails that we see. Now, the most prominent of the tails, and the one that you probably think of when you think of a comet, is known as the dust tail. Radiation, light, can literally exert a pressure on things. Now, in everyday experience, we don't see that. We don't really experience that because the pressure is so slight. So obviously, the light in this room, I can't feel the photons hitting me and feeling pressure from it. But once we get into deep space and you start talking about nearly microscopic particles that weigh nearly nothing, that radiation has a much larger effect, and it literally is taking that coma and blowing it behind the comet, and that creating those nice, beautiful dust tails. And one of the distinguishing features of the dust tail is an arc, and that essentially traces out the path that the comet has taken as it goes along. The other tail, which is harder to see, particularly probably tonight with our setup, is what is known as an ion tail. Ion tail results from the fact that when the comet sublimates, not only do water vapor and dust pop off, but also electrons, and primarily electrons pop off, and you have these free electrical charges that are hanging out in the coma of the comet. And so we have this thing called a solar wind. These are lines of magnetic force that emanate away from the sun and stretch out into the outer part of the solar system. And lines of magnetic force will attract these electrons and force them out into the outer part of the solar system. And this is a very straight and typically very blue line, or very blue tail, as it goes backwards. So when we are looking at this particular comet, according to the information I've found, the coma, well, that's a double image, is it? Yeah, it's a triple image. Yeah, there's three comets there.
It was getting a bit off-centered.
Sure. So there.
What it is? We can't trust the mount to properly dither because there's no encoder tape, right?
I don't know. I haven't figured out the extent of that problem, because I know that maximum, when you try to control the telescope with maximum DL, or at least when I was trying to do it with the pointing model, when I was trying to use fine adjustments, the software lost its mind. It didn't know what I was doing. I would click north and it would go into some random direction. I'd click south and it would continue to go along that same direction. But large motions that are larger than 3 arc minutes, it didn't seem to have a problem with. So it's possible that dithering may be problematic. Ooh.
What's this? R.
That's R. Man, that sucks that we have that gradient. Yeah, if I may, I'm going to take control for a second.
Go for it.
Do my little trick here. Yeah, we're still losing it. I wonder what would happen if we actually did a really, just a really long exposure in each of these filters. Like once this is done, I wonder what would it look like if we took a 2-minute in each filter.
We can try that.
Yeah.
I mean, I have it set to go for like 5 hours, which is, there's not 5 hours of nighttime left.
Yes, because of my personal schedule, I will probably only be doing this live stream for another say half hour, 45 minutes before I shut it down. So what was I going to say? Yeah, the reason for the folks back home, the reason why I was thinking of taking just long, deep exposures is I mentioned that the coma should be around 10 arc minutes. To give you a sense of scale, our CCD is 25 arc minutes square, or 25, 26 arc minutes square. So the coma should encompass basically or a little less than half of the field of view. And so I'm wondering if we take a really long exposure, whether or not the signal from the coma, the photons from the coma will actually pop out from the background. And we might be able to see that in a little better detail. Right now, what Owen is doing is he's applying a strategy known as track and stack. The idea here is if you, for one reason or another, cannot take a really long, deep exposure of an object, either your tracking is bad or you might have image artifacts or whatever that get worse with exposure time. What you can do to bring out the signal from the noise is take a whole lot of short time exposure images and then literally register them on top of each other so each image is aligned properly, and then you literally add them. You co-add them together or stack them together, and that makes the image pop out. Basically, from a statistical point of view, the source grows as the number of images, whereas the noise grows as the square root of the number of images. So the source signal will build much faster than the noise that you're introducing by combining these stacked images. So. Oh, here we go. 2 minutes. Why are we only seeing? We only seem to be seeing that problem in R.
Yeah. Is it something with the filter itself? Did the CCD come off when optical guidance was here?
Nope. Not the only thing that didn't get messed up. But
oh crap! I think the tail extends a really, really long way. I thought I saw some up here.
I would not be surprised by that. Oh, sorry, my cat's attacking me again. Not really seeing it. sometimes taking an image or a negative of the image helps bring out faint detail, because we can see black on white better than we can see white on black. Yeah, there's this kind of structure here, but I think that's artifact of the image. I don't think that's real, but I can kind of guess that it's like here.
Still not blowing out.
Definitely got more of the coma, but not.
Yeah.
What filter is this? This is green?
This is green.
I hesitate to ask, but what does this look like in R?
2 minutes an hour?
Yeah. If you folks watching at home have any questions, feel free to put that in the chat. I will be happy to answer it for you. I cannot answer why my other cat is crawling all over me for some reason. You have food. You have water. What is it? You don't drink coffee. So while this is going on, I just kind of want to highlight back here, we have various webcams, which we can use to monitor the situation. Currently, we are obviously, as you can see from the fact that the control room is empty, we are, both myself and Owen are observing remotely. Myself, I am at home. The telescope, there are 32-inch telescope is located up, you can see best up here in the left. Over here, you can, it's an outside view. You can peek in and see the see your telescope peeking out over there. And then the bottom right image, which doesn't seem all that interesting, is because it's not. That's really there for us to monitor the RA motor. We've had some problems with this particular tension wire misbehaving and coming undone, and so we decided to put a camera down there to help us try to diagnose why that thing is misbehaving. And I think, so you might notice there is this glow in the background. What this camera is got a night setting, and so we're looking somewhat in the infrared, as it were. And the webcams all have a light on them to illuminate, basically to make it brighter in the IR part of the spectrum. Ooh, I think you should do a sequence of 2 minutes. I know you've got that crap there, but maybe that'll flat out.
What's the sky's at 4,800? Why is it so bad? Why is the sky value so high?
So I think, so I don't know why it's affecting us now as opposed to before, but the light on the webcam, I think, is casting too much light. So one of the things I wanted, yeah, in red. I think it's leaking into the red now. I think that's my best guess at this point. Unless the moon is up. That would be a no.
Nope.
Say hello, Luna. You don't do that.
Whether we do like 60 or 120, it's same
Yeah,
same amount.
I would still do. I would still up the exposure on R. I know the gradient looks bad, but I think
Okay.
that hopefully that will, like I said, that will flat out. One of the things I want to do is to test this is to test this is to go in there at some point and put tape over that red light and see what that does.
Where were we pointing for research? Wasn't it?
I'm not sure.
I don't think we were pointed in. No, because I remember the telescope having to exclude quite a lot. So this gradient is similar.
Okay.
So this was the beginning of the night. Holy crap, 502? That's a lot of images. But
Yes,
now
it
the
is.
gradient's different.
Yeah, see, that tells me that it's some kind of local light source. It could be that even though the telescope is pointing in the other side of the dome, it's reflection off the dome. And Carl Maquette is probably more fascinated with the cursor going around the screen than she is with the actual comet themselves. Hopefully she doesn't try to take out the monitor. This is the Sky program that we use to move the telescope around. And basically it's a very powerful interface. It's as simple as point and click, or as complicated as putting in your own right ascension declination or stellar coordinates and your own tracking rate. What is an astroberry? That I couldn't tell you, Carl. I could not tell you what an astroberry is.
Sounds like a Raspberry Pi.
Yeah. Oh, mobile dome. Software for the Pi. Yes, you're right.
Ooh.
Let's see. Oh, what's going on?
Oh, you're in the corner.
There we go.
Oh wait, has it moved that much? What was our first exposure?
I'm gonna guess 1.
Yeah, I gotta look for it. Yeah, look how much it's moved.
Oh wow. So yeah, if you check it out, these two reference stars, this is the one that I'm pointing to is the first image of the night. Here is the 2 reference stars, and then here's the most recent image. These are the 2 reference stars I'm talking about. So yeah, it's moving at a fairly good clip. So what? That's probably 5 arc seconds in 20 minutes.
Yeah.
So, and yeah, and it's roughly moving. The tail is roughly behind it, so that makes sense in its orbit. So hey. Oh.
It gets brightest
On the 13th.
the 7th is closest approach to Earth.
Is it 7th? Okay, I thought it was 13th. One of the things that might be fun with this is, take images that, don't look like that, and stack them so that, well, you're going to be doing this. Ooh, that's going to present an interesting challenge. Because you can't track and stack normally. You can't track and stack with the stars. You actually have to, I think you're going to have to manually align each comet.
Cyril has a thing where you can select like that comet and it'll align.
Oh, all right.
Like similar to planetary, you can just select one sort of thing and it'll stack.
Okay.
Because I have no idea how to do it manually.
Yeah, it's trying to think of how you would do it. I don't know if you can do it in AIJ. In MaximDL, it's I wouldn't say trivial, but it's easier to do manually in MaximDL than it is in Astro ImageJ. All right, Carl. Thank you for coming by. I'm sad that your phone is running out of power.
Rest in peace, phone.
Yeah. But one thing we could do that would be really cool, I think, particularly for tours, is making a GIF or some kind of animation showing it moving.
Okay.
I think that would be really, really cool, particularly if it's moving this quickly. Let's see here.
I have no idea how to do that, so
yeah, I'll have
you want
to.
to.
I will have to. Well, I'm wondering what would happen. It'd be crude, and it probably would only look like a blur. But if you were to stack the images via stars, then you at least see the path of the comet as it was going by.
Yeah.
But yeah, it would basically look like a long white streak. But
That's how you see the kind of star trails I get.
That'd be weird. So the other thing that this thing, or the other thing that this gradient thing might be related to is if you look at the images close up. Although it's not that bad. Oh yeah, it is kind of bad here. You can see on this particular star and that particular star. Let me zoom in on this one. It actually kind of looks comet-like. That is looks like coma. And so what we think is happening is we were out of the primary mirror actually was rotated 12 degrees off its fiducial point. And so when Steve from Optical Guidance, he looked at that and was like, all right, we need to fix it. And so he rotated the mirror, this 32-inch mirror cell, 12 inches. And he had to collimate it. And so I'm pretty sure that the collimation is a little bit off. So whether or not that's causing such a dramatic effect in the gradient, I have no idea, but that's the only other major change that I could think of. But I still think that that's probably a local light source.
Because it's not in any of the other filters.
And previously, one of the reasons why I is so horrible to use is because that gradient is there in I.
Oh.
But it was never this bad in R until now.
wonder if the near-infrared camera infrared reaches any of the wavelength that camera lights are in.
Yeah, I don't know. I don't know if it's. I would imagine yes. I think the answer to that question is yes. It's the thing that I don't understand is why has it seemed to have gotten brighter since the OGS was.
Sabotage.
Good song. What?
Okay, we really don't need dithering.
No, not for this. So this is an interesting object in that it has exceedingly high eccentricity. Its eccentricity is actually higher. Well, what I saw was close to 1, meaning that it's a hyperbolic orbit. I don't remember this being considered an extraterrestrial object, so I'm wondering if that estimate is a bit high. But in any case, we will not see Leonard again in our lifetime. Leonard is the orbital period is very, very long, if at all is actually periodic. Inclination is very high, so it's not in the plane of the galaxy or plane of the solar system, as you can see. Oops, where is it? What did I do here? Oh, it's down there. Okay. As you can see here, the orbit of the plane of the Milky Way is not Milky Way. The plane of the solar system, or the ecliptic, is shown can be easily seen when you flatten everything out. No, there's Pluto back there. Still a planet, by the way, at least in my opinion. You can see the orbital path of Leonard is much inclined to that. So if it is a solar system object, then more than likely it is from the Oort cloud, which is an immense cloud of comet-like bodies that are traveling in I would say random orbits, but that probably might give you the wrong impression. They travel around in orbits that are random in their orientations, in the sense that if you look at the orbit can be characterized by 2 factors. There can be characterized by a number of factors, but 2 of them are the eccentricity, or how circular the orbit is. An eccentricity of 0 is a circle, and eccentricity close to 1 is very, very elliptical. And the other is inclination, just how well does it fit within the plane of the solar system. Most planets in the solar system, if not all the planets, depending on your how you define things, have orbits that are very circular and have very low inclination. The Oort cloud, you can have circular, really elliptical, in the plane, out of the plane. It's really anyone's. You can really have any sort of orbit that you'd like in the Oort cloud. And it is immense. It is about 100,000 AU across. To give you a sense of scale, Pluto, the distance out to Pluto is around 40 AU. So the Oort cloud actually extends beyond what we canonically refer to as the solar system. It enshrouds the sun and the planets. And so this comet probably came from that, somewhere in the Oort cloud.
That's where most comets come from, right?
That's where most long period comets come from. And by long, we're talking about periods of over 100 or 200 days, years, 100 or 200 years, depending on who you talk to. Short period comets like Halley come from the Kuiper Belt, which is a more constrained region of space. Oh, what's that? What is that?
Cassegrain.
Oh, it looks like, I don't know. It's weird. It looks like there's a, looks like it's shifted very minutely in the beginning.
Oh, yeah, that's me.
Probably did. All right. Yeah, so the short period comets come from the Kuiper Belt, and then the long period comets from the lower cloud. And the Kuiper Belt is more constrained. The orbits are much less or more close. More of the orbits are circular, and more of the orbits are inclined into the disk of the solar system. My first foray into astrophotography was actually a comet. I was, yeah, when I was an undergraduate, I was at the University of Florida, and I was using the 30-inch at Rosemary Hill. Shush, I'm telling a story. I don't care if you've heard it before. I was at the 30-inch, and the 30-inch was a Newtonian. So this is again, for the folks back home, this is a Cassegrain design, meaning that the eyepiece is at the base of the telescope, right around in this area. That's where the camera and eyepieces are located. For Newtonian, it's near the top of the tube, and so back in my day, the system was not automated, so it didn't just change filters on its own. Someone actually had to be at the camera and manually change the filter. And of course, because I was the undergraduate and the other two folks who were observing were graduate students, I got to be the monkey on the ladder, freezing my ass off, switching the filters. But yeah, we were doing the reason why we're out there, we're actually looking at asteroids, and we're using it we're taking visual observations, BVR and I think. We're taking those observations of these comets to help calibrate the ISO or infrared satellite that was going up, which was cool. And then Hyakutake came by, and that was a beautiful comet, like the dust tail. We actually took I think it's like 8 or 9 images, and had to mosaic the thing. The tail was so long that it was not visible in one field of view. It was amazing. So ever since, Comet Hyakutake is my favorite comet. It's not Hale-Bopp or Neowise. It's Hyakutake. Yeah, you can, let's see here. Can almost make out sort of the shock, what we refer to as sort of a shock wave, where the comet is passing through the inner solar system medium that is much slower, and it's going to update.
If you're around in 70,000 years, it'll be back.
There you go. All right. This is R. Yeah, you see much less of the shock with that, but yeah, I'll be real interested to know what these look like in 3-color, because you see far less of the structure involved in the R filter. It's what we were seeing here is primarily or reflected lighting and dust that is coming off this, which is much more homogeneous than the ice crystals, I think.
It's gonna have to wait till after finals.
Yeah, I would imagine. Let's see. What is that? One of the other interesting thing, or one of the other fun things about the Hyakutake was that we actually imaged a galaxy in the tail. Really small spiral, but it was there.
Yeah, I don't know. I think earlier it passed by something interesting. Yeah, passed sort of by M3.
Is that a globular?
Yeah.
Yeah, I keep forgetting.
Oh, maybe M64. Well, I don't know what. The Sky Live planetarium is kind of funky.
So, yeah, let's see what we can. Let's see. Auto. Nope, that doesn't really tell us anything.
Oops, sorry.
Oh, that's all right. B is probably the wrong one to do this with.
The Comet's pretty bright in B, though.
Yeah, I think, well, V is going to be the most optimal because we get the most light out of V. There's the most throughput from V. Oh.
Damn it. That one wasn't me.
That's an RA jump. We have that problem with this particular telescope, is that for some reason, every so often, it decides, nope, I'm not going to point that direction. I'm going to shift over here and then shift back again. That is what else can we say about Comet Leonard? So how are finals going, or end of classes going?
Good. I'm writing a paper.
Yay!
That's about it. I need to study for my other classes, though. Again with the jumps.
Yeah, it's going to do that for a little bit.
I want to move it back because it's getting a little close.
Yeah. But it's definitely trucking along.
Yeah.
Yeah, I'd say it's moved anywhere between close to 10 arc minutes in the last 45 minutes or so. Yeah, I currently have Michael Reef's paper on my desk, which is for my observational techniques class, Grazing on the Precipice of Observability, TOI 3695.01. Such a romantic name for an exoplanet candidate.
Yeah. Was it like a particularly shallow transit?
Yeah, I can tell you. Let's see here. We should have this. Up. Well, that doesn't tell me. Does he not give me the transit depth?
Gotta be in this figure.
It's gotta be in his. It's gotta be in here somewhere, and he is. Holy crap! Wow, that is way more than I was. He goes into Bayesian statistics, which is not something I was expecting. Okay, this will be a fun read. Let's see. No, but I can try to. I get a light curve. Here we go. Transit depth in R.
Oh, here's V. Didn't you want to play with it?
Oh yeah. Transit depth is roughly 3 parts per thousand.
That's pretty shallow.
Yeah, it's pretty. It really is. But his RMS is pretty good. Oh, you go over there. I'll talk to you. What was it on? Yes. Histogram. Well, that didn't work.
Such a romantic name for a comet.
Leonard. Yeah, well, you know, they can't help who discovers them. It's about the only thing that you can left that you can actually that you discover, and they actually stick your name on it.
Oh, go comet hunting then.
Yeah, definitely make Shoemaker-Levy 9, discovered by Eugene Shoemaker. Eugene Levy, I think. I could be wrong about that. I think it is Eugene Shoemaker. I can't remember who Levy is.
That's the one that hit Jupiter, right?
That their 9th discovery hit Jupiter. So Shoemaker-Levy 9 was that. So yeah. So some of these folks have
big comet hunters.
Yes, they are famous comet hunters. And I don't think they have. I don't remember. I don't know specifically what their rig is, but I don't think it's very large. I don't think their telescopes were very large. So, for those of you out in the audience, if you have a reasonably good-sized telescope, or particularly clear with very clear optics, you could comet hunt yourself if you've got the patience for it. I don't. Looking at the same parts of the sky over and over and over again, hoping to find something that's changed, that's a bit outside of my wheelhouse.
Sometimes I get the urge to point this telescope at Ceres. It's just a tiny. It'll just be a tiny dot. It'll be indistinguishable from the stars.
Oh, okay. You mean, all right. I thought you meant Sirius. I was like, oh, you just want to saturate the chip? Oh, you mean the dwarf planet Ceres?
Yeah.
Okay. Yeah. Basically, yeah, exactly. It would look like, oh, look, there's the closest dwarf planet, and it looks pretty much like all the other stars. So, woo! But you can still say that's with Pluto. Pluto isn't overly gorgeous or great in this with our telescope, but I can now say I have taken images of the planet of Pluto. So, Colon, good morning. Morning from the UK. Yeah, well, for you, it's like normal morning. Something like, what, 9 in the morning? Here, it's 5 in the morning.
Sorry for the crinkly.
That's all right. I'm going to need to be making coffee at some point. And I really wish he hadn't included that blot. It's just an ugly blot.
What happened?
Oh, he included it. Michael included essentially the what's the word? What would be the best way of describing this thing? It's a plot of correlations between parameters, and it's really boring.
The
It's really.
Aviva plot.
Hmm.
I don't know how to read those.
They're really boring. They're really. Basically it's a lot of data in a very small area, and it's not a. From a presentational standpoint, it's not useful because most people are not going to know what they're looking at when they look at this thing, or even be able to read the damn axes. Shit. But it's important. He probably should have highlighted one or two of these because there is actually something significant in here. One of the things they found was that he cannot constrain the mass very well. The mass is degenerate to what's the mass is degenerate to? I think the radius.
Did you
Yes.
get RV time on this?
No, he didn't. This was taken with our telescope actually.
Okay.
So he has provided evidence to suggest that he is seeing a brown dwarf, if I'm not correct. That this is not a planet. This is actually a planet about, let's see, does it have a 30 times mass of Jupiter?
All that from a light curve.
Yep. I wish he had made that picture bigger. Really wish he hadn't put that in appendices.
What time is the sunrise?
Oh, no idea. I can tell you. Let me get my phone because I've got an app for that. According to my sky clock later, sunrise is at 7:12 a.m. So dawn is at 6:42 a.m. So you've got basically another hour and a half before the sun gets, the sky gets too bright. Stevie B, we feel your pain. This is actually, I'm glad that we've gotten a good night on this because we haven't had the best of luck in terms of weather recently. Excuse me. But those of you who are coming in, this is, oh yeah, go ahead.
And usually when I plan astrophotography with the telescope, the weather just has to go bad.
Oh, of course it does.
So it's interesting that it worked out tonight.
I like it. I'm hoping that we will be able to do this again, like maybe in a week or so.
Same comet?
Same comet, yeah.
Okay.
Maybe if it's higher up in the sky, it'll. Because right now, what is the altitude of this thing?
Skyline says 32.
All right. So yeah, if we could get this thing near zenith, like if we can get that at 76 or an altitude of 76, that would be awesome.
Yeah, I don't know what time it. Let's see that. We can figure it out.
Oh yeah, Colin, I'm on Bob's Discord. I actually, on a couple of occasions, have caught some of his live streams with his telescope. His setup for a citizen astronomer is really nice, really sweet. Let's see here.
I'm afraid it's only going to rise later and later.
Oh. All right. Well, at least we'll have tonight, but it would be nice to see it later on.
Yeah.
Yeah, those of you who are just joining us now, we are looking at Comet Leonard. We are taking 3 color images of, well, we're taking images in 3 different filters, a blue filter, a green filter, and a red filter, with the hope that we can, Owen specifically, is going to combine these and create a 3 color image, hopefully, of the comet so that we can see, at the very least, the nucleus, the coma, and the dust tail of the comet, and possibly see the ion tail, although it's not tremendously obvious from these rough images that we're seeing here. What was I going to say? There was something else I was going to say, but then I've completely forgotten what it is. Oh, Stevie, you've gotten a new telescope and not been able to use it yet? Yeah, that I can understand why you'd be frustrated by that. What is your scope and mount? I have been blessed that in my essentially astronomy career, I have always worked in an institution that had a large telescope. So I have never owned a personal telescope. I can admit that, because Skywatcher 250 Newtonian. I will have to Google that one. I think I know what that is, but oh yeah. Those are, yeah, I like those. So Dobsonian? Oh no, equatorial. No, you said it was Newtonian. Equatorial Pro mount. Nice. Very nice. I frequently recommend, that's why I knew the Skywatcher name, because I actually recommend them to folks who are just starting out. I recommend the Dobbs, because they're, oh, stupid. I don't want you to do that. I recommend the Dobsonians because they're much easier to use and to manipulate. Why is my computer doing this? I don't want you to. See, is it a 10-inch? Then yeah, if it's very heavy, you probably got the 10-inch. It's funny, when I look at the comet, that image in the live stream, I can see more of the tail than I can looking at it through the VNC window.
Oh, every time.
I'm like, all right. Interesting how that works. But yeah, it's really annoying because you kind of want to just scrub out that bright area.
We had the same phenomenon with the little dumbbell nebula.
Mm-hmm.
What a program, BNC.
Hopefully, I can remember today. I will definitely go up there and put tape over that damn light and see what that looks like. I'll have to remember to tell somebody I did that, though. Yeah, I talked about this before. I don't know if you caught it, but yeah, the security cams that we have are night vision, in that they have a little red light that shines that normally you really can't see from your naked eye because our eyes don't go into that range of the infrared. Um, but the cameras pick the infrared camera, the security cameras pick it up, and so does our CCD. So I'm thinking that that was a poor design on our part. You know what did change was he knocked down, although again, I don't think it'd be that dramatic. Um, he knocked over this camera down here, camera 4,
Hmm.
and I had to readjust it. Although it looks pretty much where it was beforehand. I don't know. I don't know.
But it's also just like pointing this.
He
I
also
guess
put
there
on
was just some.
the plastic cover.
Oh, that could do something.
That could scatter the light more. Interesting. All right, let me write this down. So, webcam lights, plastic cover on off. Okay. Yeah, I have to play with that. What's the weather look like the rest of the week? Do we know?
It's gonna snow on Tuesday, I think.
Woohoo! Snow! Bad for weather.
Last check this morning. Oh, 80% chance of snow on Wednesday.
Sweet.
Monday, rain.
Great.
Saturday, Sunday, rain. Thursday, Friday, cloud. So, not too great.
Yeah. All right. So I was wondering whenever if I were to do adjustments, just wondering um, how quickly those could be tested.
Probably Tuesday.
Yeah, I'm guessing.
Or actually, what does the handy dandy weather thing say?
Not sure.
Might be sometime Sunday night. Tuesday. Yeah.
Yeah. Right there. This comet. One of these days, I might have to splurge and just buy a 3-color camera that we just take literally a digital camera, just slap a DSLR on the back end of a telescope just to be able to make a pretty picture without having to do all the work.
Yeah, I was thinking about that.
This is
Where's the fun in that? Oh.
Good point. Good point. You definitely see the difference in the R images and the B images in terms of structure. Here, the tail in B, the tail is not nearly as prominent, but the coma is, which is what you would somewhat expect because of the coma is primarily dominated by ice, whereas the tail is dominated by dust. Cool. And if you're just popping in now, when we first started this, the comet was over here. Now it's over there. So if anything, we have shown that there are objects in the sky which move relative to the stars, other than planets. I'll fix that. Boom.
And a couple images think we should readjust.
All right. I think in a couple of images, and I'll probably end the stream around in about 10 minutes.
Okay.
I'll go live for 1 hour and 30 minutes, so that gives me about 15 minutes.
Cool.
So yeah. Then I will definitely need to get coffee. Yeah, see, all right. I don't know if you can see this, but this is essentially the money shot. This is the transit, right? You can see how small it is in relation to the rest of the paper. This is that MC plot. Like, it takes up an entire sheet. Like, priorities, man. No one cares about this. People care about that. You've basically you're burying the lead. Appreciate that, Colin. I don't know if you were here, but I'm probably going to be dropping off in about 12 minutes or so, because I've got my own live stream to do in a few hours. I'm going to be on the flip side in about an hour and a half. So today is busy. Then, of course, I've got my day job. Actually, I have to grade stuff. Mm-hmm. So what is the topic of your cosmology paper?
It's the Big Bang.
The Big Bang?
Yeah.
Excellent. Yeah, I've got a lot of Big Bang, dark.
The most readily available information that shows it.
Yeah, I'm going to have a lot of papers on the Big Bang. A few papers on dark matter and a couple more papers on dark energy, and then some rando papers. Just, I decided, sure, why not? Like, one of them is, I think, going to be a anthropological study of what the creation myths across various cultures. I'm like,
that's cool.
Sure, I'll buy that. I'll read that. Mainly because I find that to be interesting. So sure, that's cosmology. Yeah, you can almost see the head of the comet, or the nucleus of the comet, is blunted.
Yeah.
Downloading. There we go. Why does that not seem to change it? No, that didn't work. Ooh.
Hmm.
It's tough to tell if that's all comet or if some of that is image.
I think a lot of that is
Image.
artifact. Yeah. Just because it's kind of in the center.
Mm-hmm. Is it not exposing?
It is.
Oh, all right.
Shading filters.
Got it. This is the first comet we've imaged here at George Mason, isn't it?
No, we looked at DOI.
Oh, that's right.
But that was, I looked at it once, but the sun was already up. And then Michael Reef also had to go at it and got an actual image. It's somewhere.
Tours. There it is. It's not bad.
So, yeah.
A little bit of artifact on the right, but yeah. It's not bad at all.
No. But now we have the opportunity to one up NeoWise.
Mm-hmm. Don't know why that was saved, but sure, why not? Ghost Andrew.
There's Patrick too.
Oh yeah.
Yeah.
I think over break I might actually finish that Andromeda mosaic that I started a long time ago.
Oh, didn't you want to do like a GMU deep fields?
Oh yeah, I did want to do that at some point. Definitely after we get this lighting situation fixed. It would be good to. I don't know why Betelgeuse behind clouds. Why we have that image. It's It's a dot.
Um, so are most stars.
Yes. But it's a single dot. Like, you know, like, all right, Betelgeuse. Woo, it's not like we can resolve it. Yeah, we have. Yeah, there really isn't a whole lot in the sky near where we're pointing, at least from a Messier standpoint.
Yeah. But Orion's up.
Oh yeah,
We're getting to be up finally.
yeah. Oh yes. Over break, I will be requesting 1 or 2 nights to image the living shit out of that thing. Just because this is a beautiful for that image. This is I would almost say this is an optimal field of view
Yeah.
for the Orion Nebula.
This is our current success galaxies. This is our current Orion Nebula.
Yeah, we can do way better than that. Oh, you definitely can see the nebulosity in the companion or the other sort of companion nebula, but it's all part of the same giant molecular cloud complex. But this star is lighting up this part of the nebula.
Is it Flame or Running Man?
I'm not sure. Yeah, Colin, this is in the constellation of Orion, and Orion is now becoming a very high object for us. There we go. Well, no, that's Pillars of Creation.
Blurry.
It's blurry, but it's considering what I thought we were going to see. That was pretty nice.
Yeah.
Yeah, the Orion Nebula is my favorite object. So I will be over break when we have when I don't have as much going on. I'm going to be taking images of that thing. I'll show the Trifid, Trifid, that one, Trifid. All of these images were taken here at George Mason. And this was taken by Owen.
Yeah.
And processed by Owen. That is nice. I love the contrast between the blue and the red.
Yeah. It really, like, from the raw images, it's like, what? Nothing's going to happen. And then this happened. So I'm pretty happy. There are a little bits of artifacts here, which I don't know why they're just straight red dots.
Oh, it could be they could be hot pixels only in the red images that the
Yeah.
software just didn't clip.
So, you know,
Still, it's a pretty image.
I do want to redo Bode's Galaxy.
Mm-hmm. Get rid of that vignetting.
Yeah, the sky is green.
Yeah. Bode's Galaxy, I'm assuming is that summer?
It's no, it's year round.
Oh, so it's circumpolar.
Polar.
Oh, all right. Oh, yeah, we can definitely do that.
But it's close to the
Close to the horizon. Wow, circumpolar kind of is. Oh, so right now it's actually pretty high.
If that's too close to Polaris, so like if we track it for a while,
Yeah, you'd have to be very conscious of tracking to make sure that you don't, run. Although, at this point we don't have an encoder tape, so that 8 hours plus or minus, we don't need that anymore. Because we don't, because that was to keep it on the encoder tape, and now we don't have one. So,
Perfect time.
yeah, exactly. All right. Speaking of time, I am going to shut down this stream and call it a night because I've got things I need to go take care of. Thank you, Owen, for doing this and for allowing me to look over your shoulder while we do this. So, all right. Yeah, I hope so. I hope people enjoyed it. And we had, I think, a peak number of watches. We've had 6, which for me is excellent. So thank you all. Thank you all in the chat and those of you who are watching. I really appreciate you all coming by and checking this out, particularly this this early in the morning. I know it's not quite 6 in the morning for those folks in Europe, but it's still early morning. So I appreciate all everyone coming out to watch. All right, let me mute this for a second. All right, folks.
Good night, everyone.
No. Good night. Again, thank you all for coming, and I hope you enjoy it. And if you're coming in late, please feel free to catch the early part of this where I talk more about the comet itself and our setup here at Georgia State. But bye for now, and I hope you all have a good Sunday.